Okay, hi, this is the first class of the semester, and this is the first topic we're going to be covering today, and the concept of function inverses. Now, something very intuitive, I believe, and I'm going to start just right now with something that you may have seen before. Every time you have to travel abroad or you think going to somewhere like the UK or the US, you have to deal with this their metric system, particularly one that it's very different from ours. It's the one regarding temperature. So I'm going to start out with this formula. The one it's used normally to calculate equivalences between degrees, Celsius degrees, and Fahrenheit degrees here. Now, let's suppose I want to know what's the equivalent in Fahrenheit for I don't know, some degree like 30 degrees Celsius. Something very common here in Mexico City or somewhere, 30 degrees Celsius here. Now, I'm just going to do the algebra here just to solve this out. 275 plus 32. This is equal to 54 plus 32. And we find that 30 degrees Celsius are just the same as saying 86 degrees Fahrenheit. Now, you may have seen or may not have seen this formula because it's from the physics course you have very likely in third semester. I think it's very easy. I mean, it's just a formula you have to apply to. You input the data, degrees, and you get as an output another degrees in just in a different scale, in this case Fahrenheit. Now, what I'm going to do is I'm going to write a diagram here. I'm going to write this. This is the set or the input from the Celsius degrees. All the possible temperatures in Celsius, and these are all the possible temperatures in the Fahrenheit scale. Now, what we just did here, we started out here 30 degrees, and by applying this formula here, there's actually a function we get from here to here, to its correspondence, which is 86 degrees. We apply this formula, which I'm going to call big F of C, this one here, saying this one here. Now, what I'm going to do, I will ask a question. We just did how to get from here to here. Now, the question is, how do we get back from here to here? And that's where our fellow friends, the function inverses, just appears now. And function inverses are the one that complete this circle here. And they have a very specific notation, which I'm just going to write here. You take the letter from this, the function you had, this capital F, in this case. Now, you take the capital F, and then you write an exponent, which is a -1 here. The rest remain the same. And this is read the inverse of the function f of c. Okay, now the question is, how do we find this correspondence, this f inverse of c in this case? Now, I'm going to do it just for this function here, the one we started with, the f of c. And the solution to get this inverse actually is very simple. You started with the same one here, times c plus 32. And the thing you have to do is you have to solve this equation, but for c. You have to isolate the c here. And that's what I'm going to do. Now, first I'm going to start by subtracting 32 from both sides of the equation. It's going to be f minus 32, it's equal to 9/5 times c. Now what I'm going to do, I'm going to multiply both sides of the equation by 5/9, and then I get to this. C, it's equal to 5/9 times f minus 32. Now this new statement here, it's actually the f inverse of c, the one we started here. I'm just going to write it, just substituting the c here by the f inverse of c. Okay, and this is, now, what does it represent here? I mean, the thing is, if you input a temperature here in this f inverse of c, what you will get in return is actually how much this temperature is equivalent to in the Celsius degrees. We can just prove it out by doing this. I'm going to substitute, to evaluate this inverse function with 86 degrees here. And by doing so, I'm just going to substitute here the 86 degrees. Now let's solve this out. 86 minus 32, it's 54. 54 here. And now 5 times 54, it's actually the same we got here, just inverted. So 54 times 5 is 207 over 90. And that, at the end, get us to the fact that f inverse of 86 is 30 degrees, which is just the thing I just saw here. We complete this circle here. We started in 30, we got to 86, and then we evaluated 86 here in the inverse function, and we got back to 30. So in a way, I'm going to just to do something with a bit more mathematics here involved. I'll be doing this. I'm going to write here again another couple of sets here. Now, instead of writing Celsius and Fahrenheit, I'm going to write X and Y's. Just the same thing, just in a more abstract way. I start from here, and by using a function I'm going to call f of x, I get from the x to the y. Now, to get from the y to the x, I use an inverse function here. Now, wait, I'm going to write it here. The inverse of f of x. Now, I want you to notice something. The data or the input you place in the f of x, which is, in other words, the domain of f of x, it's actually the output of the f inverse of x. You see what we just did here. We got here from 30 degrees, we got, applying the f of x here, we got 86 degrees, which is the 86 degrees, then we applied it here in the f of x, and we got back to 30, which, in other words, the domain of f of x, it's actually the codomain or the outputs of f inverse of x. I mean, for codomain, you may have heard this as image or range. I don't know how you may have heard it before. It's just the same thing, you know. The output of the inverse function or the range of the image is the same thing as the domain of the f of x. Just the same as here, the output or the codomain of f of x is just the same thing as the domain or the input of f inverse of x. Now, I want you to see this relationship here between the f of x and the f inverse of x, between domains and codomains. Let's move forward to the first example, because I think that we clear everything out for this relationship between domains, codomains, and so on. Okay, let's move forward.